Hello guys, good day. Welcome back to my channel Arts Engineering and RH Cepeda Engineering Services. And this is Ruel Cepeda. And for today's tutorial, sorry, I'll be showing to you the tool that I have developed using the Visual Studio and C# language that can extract and generate the design result of the column from the ETABS model, as well as to generate the Rebar schedule. And without further ado, let's open the application. And I'm still developing this now, this application, but it's fully functional. You can use it, and we can use it this to create the Rebar schedule of the column. And okay, so the thing here, you need to open the application, the model, the items of model. And if you have opened multiple models, items model, it will reflect here in the section. So you need to select only one. For example, this model. I need to select this one. If it's not reflecting here, you need to click the refresh button only. And after that, I intentionally not analyze the model so that the tool can analyze it itself directly. Okay. Then once you already selected the model, the name of the model, click connect to ETABS, and the ETABS itself can identify or detect that your model is not yet analyzed. It should be analyzed first. Then the tools will analyze it automatically. As you can see here in the bottom part, it's running already. And we have here a log so that you can notice or you can identify the process, and you know the process during the analysis and the method, the steps that the tools have done. And let's wait to finish the analysis. Okay, let's wait. So it depends. It's much better if you will analyze it directly and design already so that you can extract it directly from here, from the tools. Then it's already done. I will just reset to the original position and reset the deformation contour. Then once already analyzed, after that, actually this design code, it doesn't matter because it's automatically assigned here. So it depends to you. So I will just, although it's not necessary to isolate the column because the tools automatically identify the type of the column, the elements column. So I just want to isolate this to show you guys. So once you already analyze and click connect the tools to the items model, just click the extract column design summary button. Then automatically, if the model is not yet designed, the tool automatically detect that it need to be designed. Then automatically it will run the design of your ETABS model. And as you can see, it's already running and all the columns will be designed. And of course, it should be, you need to set all the necessary parameters and conditions before clicking this one here inside the ETABS. For example, what is the type of the connection or what is the type of the structure, if it is moment frame, intermediate or ordinary moment frame. You need to set up in the override settings. Then let's wait to end the process. And in the log, you can see here, this is the step-by-step process, how the tool done the extraction process. Then let's maximize the tools. As you can see here, this is the design result directly from the ETABS. And all the columns is here already. Then after that, let's come down to the Rebar schedule. Uh, So you have an option to generate all the columns or to generate only those columns have selected in the ETABS model. So for this, let's generate first the all the elements column elements. Okay. So as you can see here, there are 518 unique elements. So very easy and very fast. We already generated the schedule of the column reinforcement. I think how many seconds only. So here, 5 seconds only. See, it's only 5 seconds. Okay, now let's go to the result. So in the longitudinal reinforcement and the status, meaning okay. So initially, this is the size of the rebar considered in longitudinal and the ties, and also in the number of legs in both major and minor axis. And if you see this okay status, meaning yung assumption size of the rebar is okay. But if you see like this, because as you can see here, the size of this column is 900 by 900. But here, it is 1100 by 1100. So meaning you need to increase the size of the reinforcement. So although the tools automatically change the initial size of the rebar here, but you can see here, so from 20 mm, meaning from 20 mm, the tool is automatically changed it to 25 mm. So if you don't want to see this like this status, just change to 25 mm and generate this. Then all the longitudinal reinforcement is already okay. But this is the problem. If you are optimizing the column section, the problem here is if you select one rebar only, size rebar only, all the section have it will assign the same rebar. So as you can see, 900 by 900, the same with the 900 by 1000, and the 1000 by 1000. This one, where is that? 1100 by 1100 is the same. So I am recommending to select or to select first the same section. So for example, for 900 by 900, select only the 900 by 900, then the other batch will be 1100 by 1100 and so on and so forth. So that you can assign it uh, typically for each section. Okay, but it's up to you guys. Okay, now let's come now in the ties. So this is in a meaning when you check here, let's go back here. The value of the major and the minor, the major first is 0. Let's come now to C1. C1. Where's C1? Okay, this C1. As you can see, the major rebar and the minor rebar of the shear is 0. So meaning it's not required. So as per code, you need to provide this the requirement reinforcement, the required reinforcement. Okay, uh, that's that's the reason why the result is NA, because the requirement is 0. But if you can see like this, so this is a requirement. So meaning the four-legged, I mean, caliber 4 from the support, then you need to provide two-legged, meaning one close stirrups only, then the size of 12 mm, 200, and the rest is 200 also. But you have an option to increase this one, the size of so I mean the number of the legs, and you can increase also the size of the rebar. It's 12 already, and you have 200 at caliber 4, then the rest 250. And for this rebar ratio, I think I need to update this one because I did not check it yet. Okay. And the good thing here, once you already extracted, by the way, you have an option to export it to the CSV or the Excel. And the schedule, you can export it to the AutoCAD file. Then, before that, let's select some of the columns to try the other button. This one, selected columns only, then select, boom. So this is the selected columns only. If you don't want to extract all the columns, and let's say this columns only, then Beulah. So this the selected columns only will be extracted here. And if you will see like this area only, so meaning you need to increase the size of the ties or the rebar or the number of legs. So here we just provided three. So let's try to put up four legs. Okay, then click here again. So meaning you need two. Let's try this one because I just set up to four-legged stirrups. Probably next time I will be increase this one because the size is 900 by 1000. So and the minor axis is 1000. So probably you need to increase the number of legs. Okay, let's try. So as you can see here, let's try 20. So but this 20 stirrup is unusual. That is unusual. It's not a normal size, so you need to increase the size and the number of the legs here. Okay. So after that, I will extract all the columns instead of the selected. Then I will use this one, 32, okay? 25. This 25 already. Select all. Then you can generate the schedule to then select yes to CAD file. And you can see here the logs. It's preparing to cut documents, clearing, and Chired drawing the rebar schedule, and let's wait to finish the process. Because I think there are 500 elements. It's too much elements. If you will work this manually, so it will take time. I think how many hours will consume that? So here it's just, I think, how many seconds only? 59. So 21 seconds, or let's say 30 seconds only. And let's go back here. And this is the generated schedule. So you can check it already here. And for this NA, as I said earlier, you need to set, you need to provide the minimum reinforcement as per the code. Okay, that's all, guys. Guys, thank you for watching, and don't forget to follow my page and YouTube channel, RHC Engineering, and also I have a website, RHC Paid Engineering Services and rhctools.com. Yan lang. Bye-bye and God bless. See you in the next video.